Well, thank you all for joining us. I'm very excited to be here. As Jason mentioned, my path has crossed with CAD Micro over the last decade plus. It's great to be back here presenting with you all. And I'm very excited to talk about technology and automation in the context of healthcare design and construction. It's a personal passion of mine. So I really do believe there is a tremendous opportunity, a tremendous potential for technology to impact the outcome of projects, and not just for healthcare, but really all projects in general. And that is why groups like BIMxt are so important, so critical for our industry. And this may sound a little altruistic, but I really do believe that great change comes when people gather and they center around a shared mission and a shared passion. So thank you all for joining us today. I'd like to start the conversation here by sharing some of the more macro trends we've observed that have really a direct impact on how healthcare facilities are designed, constructed, and operated. And this will kind of lead into some of the specific challenges we've seen and some specific project examples around all of this. But I'll start with siloed value chain here. Like, what do I mean by that? Well, in design and construction and operations, there are more stakeholders involved in the process, and increasingly, they are taking on a smaller slice of scope or risk. So essentially, what we're seeing is risk being transferred to others. And what that means for a project is that oftentimes there are poorer transitions from design, construction, operations, really just more opportunities for things to slip through the cracks and really impact the outcome of the project in the end. So that's a siloed value chain. That's how I would probably summarize that particular trend. Another trend here that we're seeing is around workforce shortage. And I think of this in a few different domains. When I think about design and construction and a project coming to life, for sure, I think about field labor, people in the field actually turning our projects, turning our concepts into a reality. There is a shortage there. As it relates to healthcare, I think a lot about the planning, design, and construction teams within organizations. They are short-staffed. And for sure in healthcare, clinical teams are short-staffed. The nurses, the providers, they are all being asked to do a lot more with less. There's an interesting stat I wanted to share here from the AGC, which is 30 to 40% of the construction workforce is set to retire in the next 10 years. So that is a big thing we all need to be thinking about. And I really think the silver lining here is that technology can help drive efficiency in project development, full stop. There's an opportunity really for organizations to leverage technology and also shore up their teams who really have fewer staff to deliver work. It's a big opportunity. The last two trends I want to just briefly touch on here directly relate to the presentation today. Advancing technology. The reality is that there are a number of tools on the market, and it seems like that number of tools, it's growing exponentially almost every day, right? So there are many technologies. A lot of times they offer point solutions to a particular problem. And oftentimes they're disconnected from an organization's suite of tools. So what you end up with is essentially this technology landscape in organizations that is somewhat disjointed. It's been cobbled together over years, and it's a really big challenge for organizations to grapple with. And again, they are already short-staffed. Their time is already limited. So big problem. And a related problem here is proliferation of data. So the reality is that our industry as a whole generates vast volumes of data, and it's all in different formats. So what we're seeing is that data management is a particular challenge. It's tedious, it's time consuming, and the reality is it results in inefficiency, redundancy, and wasted cost. So again, these four key market trends are things that we're seeing. I'm sure some of this will resonate with the audience here, and probably you could add others. But I wanted to paint this as sort of some context behind what we'll talk about in the coming slides. So when I think about project development and I think about, design, construction, the process as a whole, we really center around four major problem areas. I mean, there are many problems to be solved, no doubt, but we center around four major problem areas that we believe technology has an opportunity to positively impact. So those are underground coordination, existing conditions, design coordination, and facility data, or O&M data strategy. So each of these challenges presents itself more prominently, I suppose, during different stages of a project's life cycle. But approaching any of these with a proactive mindset can really help mitigate risk in design and construction and improve the outcome of the project as a whole. This morning, I'm going to dive into a few specific examples of these themes and highlight the role that technology played in the process. I'll kind of work my way from timeline left to right, and I'll probably focus more on the first three here: underground coordination, existing conditions, and design coordination. So getting into it, I want to start with underground coordination. This is a particular challenge that we've observed on almost every major capital healthcare projects. The reality is that many projects exist within the context of existing urban areas, and a lot of times the infrastructure and underground conditions in those areas are sometimes unknown. So this is an area we believe technology provides an opportunity, right? There's an opportunity to really allow us to create a more comprehensive view, a digital underground map, as it were, of those existing utilities, of the existing infrastructure at any given site. And there are a number of data sources out there that we can draw on to do this, like existing drawings, public records, even aerial imagery. But the reality is there's a lot of data out there if you know how to wrangle it and curate it. So leveraging even just off-the-shelf technology like Revit, Navisworks, Dynamo, along with some custom-built enhancements in C# and other languages, we're able to really programmatically spot underground coordination issues in a digital format before shovels even hit the ground. Again, tremendous opportunity here, and a lot of this could be done manually in theory. Like, you could go out, you could gather all this data individually, you could figure out the best way to curate it and spot issues, underground issues. But because we have so many technologies at our fingertips, we're able to do that, aggregate, curate significantly faster and with a higher degree of accuracy. So the example I have on screen here is what we call a composite sheet. It's really a catalog of the different underground utilities for any site. And what we can do here, again, programmatically, is highlight areas of conflict, present really what we consider a confidence or a certainty score for each utility's location. So again, when you think about a project development and project lifecycle, underground coordination is something that is such a big challenge. Utility strikes are a huge problem for our industry and very costly, but we're finding creative ways to leverage technology and get ahead of that as a problem. I want to move on and talk a bit about existing conditions. Existing conditions are another big challenge we see quite often in healthcare. The reality is that greenfield new construction projects are rarely the norm. They do happen sometimes, and we get involved in those as well. But oftentimes, existing facilities are being renovated, they're being added on to in order to refresh and provide more effective patient care. And because so many healthcare facilities are pretty aged, a lot of them are from the 60s, the 70s. They've morphed over time as improvement projects have been completed. Because of all of that, having an informed understanding of current state as-built is very difficult. I would guess if you went to almost any healthcare facility from the 60s or 70s and you spoke to a facilities guy, he probably has a little section in the basement with physical paper copies of that facility's drawings. And probably things have been slip sheeted in over the years, over the decades, but again, not necessarily a digital format and certainly not organized well. So again, this is a big opportunity for us that we see, digitally cataloging a facility's architectural, mechanical, electrical, other systems. It really provides a digital basis to compare existing conditions against new design when those renovation projects do happen. This is just an image. I love sharing this one. It's an example of a point cloud scan from a recent project we delivered in Baltimore. I want to talk a little bit more about this and existing conditions, digitally documenting, creating that artifact of the facility. The way we do this, the way we think about this is, high accuracy LiDAR scanning, photogrammetry, scan to BIM technology. These are all different tools and techniques in our tool belt to help take on this challenge of existing conditions and form that basis of understanding for as-built. In this particular graphic, you can see pretty plainly a scan to BIM mechanical model. That's what's represented in red, conflicting with a new design model represented in green. So again, because we were able to digitally catalog this particular facility, we were able to spot those issues and better resolve existing conditions with new design. I will say, and I know this is a technology forum, we're talking tech here. Technology helps us form that better understanding of existing conditions, but I will say, and I feel this way, I guess, philosophically about AI and other tools out there, there's an element of human intuition that is needed, always needed, to assess the output of what a technology can give us, okay? So in an example like this, human intuition is still needed to assess the unique conditions and determine a better coordination approach, even if the technology has gotten us 80% of the way there. I want to move on and talk a little bit about design coordination as another challenge. Again, in the context of healthcare specifically, healthcare facilities are incredibly complex spaces to design, construct, and operate. In fact, a recent statistic from Navigant Construction Forum suggests that 4 to 6% of a total project cost can be contributed to construction rework. That's a stat actually that extends beyond healthcare, but it's very prominent in healthcare. So that equates to over 100 billion annually in construction rework. It's a huge problem, right? And it's a huge opportunity. So there are many ways that technology can influence design and construction of a healthcare facility and get ahead of some of that construction rework problem. But I want to highlight a specific challenge here we've seen, and that's around the coordination of medical equipment requirements, okay? And just very briefly to paint the problem here, in a lot of cases for a project, new construction project, medical equipment is selected during the later stages of design. So what that means is that there is a gap, a tangible gap between what has been coordinated during design and what is ultimately specified in the end. So as it relates to medical equipment, essential services like power, water, data, many of those requirements are overlooked and need to be retrofit on site during construction. It's a huge problem. And this is really a problem of scale. So if you think about a singular piece of equipment, maybe it required drainage, there was no drainage accounted for on site during construction. So you have to fix that one instance. Sure, maybe one, it's not a large lift to fix, but the reality is with medical equipment, this is a problem of scale. And for most facilities, there are hundreds, if not thousands, of pieces of medical equipment that need to be coordinated effectively. So again, looking to technology to help provide a solution here, we are able to programmatically spot coordination issues by essentially comparing data from the medical equipment specifications against plans and other design documents. And once again, like we saw in the other examples, a lot of this could be done manually, but because there are so many great technologies and tools out there, we're able to leverage those to increase both the speed and accuracy of this coordination. The result here is fewer on-site retrofits, reduced costs of materials, and construction delay. Again, finding creative ways to leverage that technology to solve a real-world problem. Another related example I wanted to quickly highlight here is around doors, frames, and hardware. It's a similar problem than what we see with medical equipment. Oftentimes, the reality is that there's a mismatch between the hardware schedules, plans, and specifications. There was a recent project in an inpatient healthcare facility that we were involved in recently. It had around 2,700 doors total across all the facilities. And we spotted, again, programmatically, about 10% of those had a mismatch of hardware sets and design documents or specifications. So really, without technology, without an automated way to assess that particular project, that disconnect in the doors would have probably gone unnoticed until construction and resulted in significant added cost. So similar problem to what we see with medical equipment, a problem of scale, but one in which technology is there to help support us. So as I start to conclude here, and with those few examples in mind, I just want to kind of reiterate the fact that healthcare development is complex. There are many examples we can point to where technology has resulted in more efficient delivery with fewer errors. What we believe at Coda is that because there are so many different stakeholders involved in this process of design and construction, and so many opportunities for information to be missed, we also lean on dynamic platforms to view and resolve these coordination issues. And these couple screenshots I have here are snapshots from our own homegrown software solution that's really become a centerpiece of how we coordinate with project teams. The platform, we refer to it as Atlas, is really just a dynamic viewer. It's based on Autodesk platform services. And what we're finding is that teams leverage this technology to view project coordination issues and better understand the potential impact of those issues, both in terms of responsibility and cost. So again, more of a coordination tool than anything else, but another example of how technology is really transforming how we deliver projects in the healthcare space. So with that, you can probably sense I'm very passionate about this. I can talk a lot about healthcare. I can talk a lot about digital technologies. I'll conclude, hand it back to Jason here, but please feel free to connect. And if you're interested to learn more about Coda, feel free to reach out.
Awesome. Thanks, Alec. That was great. I find it, interesting, just something I didn't even consider, but you nailed it so well. The challenges I think you're seeing are relatively consistent. Renovations and then
Right.
spec to actual installation. But what you said, it's the scale, right? I mean,
Right.
Anybody who's worked on any healthcare or any hospital, there's not just a renovation where you've got two levels off. There's 17 different renovations, and every single floor starts at a different point or something. And
That's right.
if I'm looking around my office, well, I've got a phone and maybe a TV, but every single patient room has got to have just an insane amount of equipment. Just
Yes.
absolutely insane.
Absolutely. Thank you.
Do you find challenges? Like, I think everybody on the call here, we like technology, we understand the benefits of it. Do you have challenges, or what do you do to kind of convince the client that this is the way to go? Because it's an extra lift and it's outside the norm processes. But how do you, I don't know, how do you make it sexy for them so they want to jump on board?
I certainly think bringing cost into the equation or into the conversation always grabs attention, right? And especially like the medical equipment example, sure, $1,000, maybe $2,000 to fix one issue, it's probably not going to grab their attention. But if you tell an owner, a healthcare owner, for example, that you have 300 issues related to this particular piece of medical equipment, that's an entirely different scale of cost. So I think for sure bringing cost into it helps really make the problem a little more real, at least from an owner perspective.
Gotcha. Yep, money talks. What are you guys, or what are you personally maybe even seeing as kind of the next things you want to dive into or start picking apart?
Well, I didn't really talk much about it here today, and I know we'll talk a bit about it in a minute here. But AI, there is again a tremendous potential here, and this is a good segue. You know, beyond the core capabilities of something like an AI that can improve the process for us. I mean, there are so many tools out there already leveraging some of that technology, and the way we approach that is, in general, we're a smaller team, and there's a lot we could build in house, a lot we could do on our own, but we really do look outward to strategic partner network. Really, like what are the other tools that are already out there that may be super focused on doing something really well from a technology perspective? How can we fold that into our process and make our delivery better for our healthcare owners? That's how we're thinking about that. So AI, I think in general is really something we're looking forward to and seeing where that goes.
Perfect. Awesome. Thank you, sir. That was fantastic. And yes, that was a completely unscripted segue, but it's a great segue.